So thanks very much for coming back. I was going to say promptly, but you're not promptly. But thanks for coming back anyway. I'm looking forward to the next session because the last time I really knew Larry was about 40 years ago, wasn't it? Oh, no, not quite. 30-odd years ago, when he joined as a wet behind the ears new graduate at ICL, where I was. In fact, I wonder if we've got this slide. One of the guys in the audience in our office was an amateur cartoonist, and he would do quick cartoons and so forth. So this is, Larry was a keen abseiler, and the figure coming towards the window is Larry Cable. These days known as Crazy Larry. The guy sitting in front is Stuart Harper, who was sitting over, yeah, he is, yeah. So we're all still around, Larry, Stuart, and I, but this was Larry in his peak of his abseiling. I'll just tell you one other thing about him at that time, because we started doing projects in Utica, in New York, and New York State, upstate New York, and Larry got posted over regularly. And after he'd written off about 3 or 4 cars, Hertz and Avis said, no more cars. So that's where he got his Crazy Larry title. I take it you're not writing off cars anymore now, Larry? Not recently. Okay, good. So after studying at Edinburgh and St Andrews, Larry joined ICL, and then he joined Spider, and then he joined DEC, and then he went to Sun, where he spent 15 years at Sun working on various technologies such as the X window system, Corba, and OpenStep, the foundation for both macOS and iOS APIs, with Next Computer. But most notable is his contributions to the Java platform, where he developed and was with JavaSoft in the late 90s. In particular, he's one of the core architects of the Java Enterprise Edition, which now powers many global mission-critical applications and websites. Since leaving Sun, he has worked with Amazon, BAA as WebLogic, and then as Chief Development Architect at SAP, before joining Salesforce as their Principal Architect. So Larry's going to tell us about mobile, internet, and cloud technologies. Over to you, Larry.
Thanks, Ian. Yeah, I don't abseil anymore, and I haven't crashed too many cars in between. It's a great pleasure to be home in Scotland, and a great personal honour to be Vint Cerf's warm-up act. And so I'm hoping if I'm not educational, at least I'll be somewhat entertaining. I have to say that I'm in awe of the talent that I've shared the stage with today. I thought the previous talks about scaling and about venture capital were incredibly valuable for someone who is probably anti-entrepreneurial. The closest I've come to working for a startup was Spider Systems, and that was so long ago that I can't even remember what I did then. And I've been incredibly fortunate in my career to work for some pretty amazing companies with some pretty amazing people, and I've also been extremely fortunate in taking part in developing some technologies that have had a global impact, as Ian touched on, and I'll talk a little bit more about that in a moment. So this is kind of a change of pace from earlier today, where we were talking about getting capital and scaling your company. I've been a technologist all of my days. I still write code, not as quickly or as efficiently as I used to. But what I really want to talk to you today about is where the industry is going, what technologies we're evolving and working with, and how those technologies are going to change the way that we live as individuals, as customers, as employees, and business people. And the sort of whole theme or undercurrent of the talk is really to reinforce the fact that innovation, although a lot of innovation occurs in Silicon Valley, we're actually at a point today in terms of the number of technologies and the type of technologies that we have, that innovation can occur anywhere. And as a Scot, a very proud Scot, I've always lamented the fact that Scotland really hasn't grasped the software industry and taken opportunities that we can have. We've got a great educational system, we've got a lot of talent here, and I think that you know, there's an opportunity for Scotland to really have an impact in global software. And so the information that I want to sort of relate to you is to really explain to you why I think we're at an inflection point in the sort of technologies that we have that will allow entrepreneurs in Scotland to develop technologies and take them to a global marketplace. And so what I'm going to be talking about is really 4 or 5 interconnected themes: mobile things, cloud, big data, and a sort of cross-cutting theme of the role of open source and open APIs in those. I'm behind my slides here. I'll pass the short disclaimer, just assume that we all read that. I wanted to say a little bit about my background, because this is going to be a very sort of personal view of what's going on in the industry, and I think it's important to understand people's background in order to appreciate their point of view. As Ian mentioned, I've worked for a bewilderingly large number of companies. Most of my professional career, certainly in the 20 years that I've been in Silicon Valley, was spent with Sun. But I've also, you know, worked for Amazon, BEA, Oracle, SAP, Salesforce, etc. I've also had an interesting history in terms of computer systems. This was the first mainframe that I worked on, an ScotSoft2013 the last remaining version of which is in the National Computing Museum. Then the first workstation that I worked on was the ICL PERC system. That's in the Computer History Museum in Mountain View. The first Unix system I used was a PDP 1140, also in the Computer History Museum in Mountain View. The first Berkeley BSD Unix system and the foundation of many computer science departments all over the world, the VAX 11750, which is also in a computer museum. And the SparkStation 1, which was the first RISC-based processor machine that I worked on at Sun, which is also in a computer museum. I've also, in working with these companies, been involved in many standards organizations like the W3C, the IEEE, the X-Window Consortium, OASIS, and collaborated with companies like NIXT. The 2 most important pieces of information to take away from my background is, one, most of the technology that I've worked with is either already in a museum or will be, and I'm not sure what that really says about me, but I think it's significant. The other one, which is very important for the venture capitalists in the audience, is that there's a 50% chance that if I've worked for you or collaborated with you, that you will fail to exist as a business entity between 3 and 5 years, either being acquired or just going completely out of existence. So, you know, given the fact that you know, I've been at Salesforce and SAP, you know, you might want to look at your investment portfolios there based on that. Anyway, so that's kind of a little bit about my background. I moved to the US in 1989 to work for Sun, and had a great 15 years there. And my experience of Silicon Valley is that there's a phenomenon around Silicon Valley. It's a unique environment. It's not necessarily an environment that couldn't be repeated elsewhere, but it's just an incredible ecosystem to work in as a technologist. Fundamentally, that environment is fueled by intellectual property from universities like Stanford and UC Berkeley, but there's also a broader sort of virtual environment with great universities like Carnegie Mellon and MIT, basically bringing in IP and intellectual skills from its graduates that fuel Silicon Valley companies, and not only just in the entrepreneurial or intellectual sense, but just in sort of driving the overall community. It's a small world. I talked to Vince, and it turned out that we worked with a guy called Smokey Wallace at Digital Equipment. So even though it's a big industry, it's actually not a big industry. It's actually a small industry, and everyone knows each other. The interesting thing about the Silicon Valley is this ecosystem and how the ecosystem aligns itself around certain themes and waves of technology and innovation. And we're actually going through one of those alignments and innovation points at the moment. And these themes tend to drive the industry as a collective ecosystem. And you have an opportunity either to create these themes and lead the industry, or you can ride the wave and be equally, if not more so, successful. And so this notion of riding the wave from the technology perspective is kind of where I'm hoping to provide some value over sheer entertainment. So let's start with the first theme, which is the theme of mobile and things, and that is, I think, one of the most disruptive themes that we're working on at the moment. It's really changing the game. And the question now these days is not, will we do mobile, but it's actually, will we do mobile first? And the answer is absolutely, we have to do mobile first. If you look at the way that smartphone and tablet adoption is occurring at the personal level and increasingly at work, where the lines of personal usage and professional usage are blurring, it's having a tremendous impact on the way that we live as individuals, and this is being propagated through all aspects of the software industry as we deliver solutions. We're now delivering them primarily to mobile devices. And that initiative is really driven by adoption as in the role of consumers, things like social media, downloading apps, mobile advertising, and things like that. And so what we're seeing around mobile is that every software company in the Valley and beyond is really now moving to this mobile-first strategy. And some of them are struggling. I mean, I was at SAP for 3 years, and SAP is an enormously successful enterprise software company who didn't really understand the power and impact of mobile devices on the enterprise, and they're really struggling, but are starting to move in the direction of re-architecting the way that they deliver their enterprise software to their customers, and also their customers' employees, by restructuring their applications in that mobile space. It's a huge opportunity, and I'll talk to that in a moment. And it's also a new channel with a tremendous associated network effect with it. And I think that's what's really attracting the industry as a whole. So why is mobile important, or is mobile important? And these are some statistics that Facebook released a couple of months ago. And if we just look at their monthly and daily active users and the number of users, both monthly and daily, that are actually using or accessing Facebook from mobile devices, you see that these numbers are fairly staggering. We have 100 million daily active users accessing Facebook via mobile devices. That's an incredible community to deliver content to. And so this alone, from a Facebook perspective, explains why Facebook is investing so much in re-architecting their web presence from a browser-based desktop, laptop, tablet environment into a mobile environment, and also why mobile advertising is so incredibly important now. If you've got 100 million users, accessing your Facebook site from their smartphones, that's an amazing revenue stream to tap into with advertising. So this is the opportunity that all of the major companies, primarily in the consumer space initially, but the enterprise is starting to identify this as being a huge opportunity, and that's what's dragging mobile through here. And just to look at some of the size or the magnitude of the market, this statistic from Q4 of 2011, there's over 6 billion mobile phone subscriptions globally, and about 1 billion of those are smartphones. That's a billion devices out there that you can access content from, and that's a great market and platform to access. Looking at the mobile internet traffic, just look at the growth here over three years, and the way in which the market share, or the bandwidth, excuse me, share of mobile traffic has grown in magnitude, but is also in how it's shifted. As you can see, and this statistic was quite surprising to me. I didn't realize that mobile video access was such a large segment of mobile bandwidth as it grows over from the next 3 years or so. It's pretty incredible. You also see that the data segment as well is 20% of the mobile network traffic, and voice is dropping. And as we'll talk later, you'll see that machine-to-machine, or the Internet of Things, is actually also starting to grab a significant percentage of that mobile bandwidth. If we start to look at the devices themselves and the amount of growth in the market, this is a slide showing the unit volume of iPad, iPod, and iPhone shipments, and you can see just how incredibly successful Apple have been, and this is why their stock is where it is. I think this is actually interesting to see that in fact the iPad growth here is almost 3 times that of the iPhone. And I think that's something that we generally overlook. When we look at mobile, we think of this huge opportunity of the mobile platform, but we actually now see that the tablet segment is enormous there. And tablet is significantly different from desktop. If you think about how you interact with applications in your laptop or your desktop versus how you might interact with applications on your tablet or on your smartphone, it's 2 completely different user experiences, and applications that are suitable for one user experience are completely unsuitable for the other. So you really have to, there isn't one size that fits all here. So what you're going to see over time, I think, is a movement from applications that are primarily designed to be used with a keyboard and a mouse to applications that are designed to be using with touchscreen technology. If we look at Android's growth in the smartphone market is even larger. I mean, it's clear, as we'll see in this slide, the growth of the market share of mobile OSs it's changed over time. I think this slide to me is most telling because if you look back in 2005, you see that the Symbian operating system for Nokia and Ericsson and the European device manufacturers had, almost an overwhelming market share, 60% of the devices. And now you look at 2012 here, and where is Symbian? To me, this is a clear message that if I'm building mobile software, there's exactly 2 platforms that I'll build it for. I'm not going to waste any time or resource elsewhere. I think the interesting question here, which is not at a global level but a regional level, is what the impact of some of the developments in China are going to be, where some of the Chinese phone manufacturers are starting to use Linux distributions as a foundation for their own mobile platforms. So we might see some regional fragmentation of the OS market share there. But this to me basically says you have to build for Apple and you have to build for Android. The real challenge from a sort of technology perspective in doing this is and it's quite a hurdle at the moment. It's from what I'm seeing in the industry, it's actually proving to be quite a significant barrier to the sort of velocity associated with mobile application development. There's first of all the multi-platform issue. So if you are serious about developing mobile apps, you have to develop for iOS and you have to develop for Android. iOS is a native platform written in Objective-C. It's actually difficult to find Objective-C developers. I happen to be one, just FYI, although it's been a long time since I've written any. That was mid-1990s when my son was working with Next. Versus the Android platform, which is Java, yay, which is great. So, you know, it's really difficult. You basically have to build two completely separate applications. There was a lot of hype surrounding HTML5, CSS3, and JavaScript as being, you know, the next wave of how you would construct applications and browsers. In all honesty, what we're seeing is what we expected to see, which was that it's not a panacea. It's really difficult to build, you know, really great user experiences that are portable using those technologies, primarily because what's a technology called WebKit, which is essentially a browser platform for the mobile environment, isn't a complete solution, so there's only limited amounts of the user interface that you can develop in a portable content versus developing, you know, a high-fidelity user interface on the native platform. Other things that are kind of making life difficult, of course, the Android platform being multi-vendor means that you have multiple devices, and that really messes up your testing matrix. So, you know, the cost of developing Android mobile apps and releasing them into the marketplace is much higher than the cost for iOS, because there are fewer devices and it's a single vendor. And so, you know, that's something to take into account. But it's a cost that you have to adopt because of the market share that Android has. And then last but not least, there's a considerable barrier to entry for using mobile apps in the enterprise environment, primarily because of security concerns about exposing enterprise data across the enterprise firewall to mobile devices. But that's something that's being addressed. Let's talk about the barrier or lack of barriers to entry into the mobile marketplace. Here's some statistics about the number of applications and downloads from the Apple iStore. And as you can see, as of about a year ago, there were 600,000 App Store applications and about 25 billion downloads. That number, of course, is hopelessly out of date. It's over a year old. The number of apps is closer to, I think, 1 million now, and they've had like 60 billion downloads. Likewise, the Google App Store have had about 25 billion downloads. If you think about that, you know, we could basically sit down this afternoon, write a mobile application, deploy it into either the Google Play Store or the App Store, and I would have a potential customer base of 1 billion plus users and volumes of, you know, millions of downloads. So as a channel to deliver software product, the mobile platform and the various app stores associated with those mobile platforms, it's a disruptive change in the way that you can deliver your software product to a global market, which we never really had before, right? If I was a developer in Scotland up until this time, if I wanted to get my software in a global marketplace, it would be a real struggle. Here, basically, I upload it and I'm there. I'm in every market around the world. So that's a real opportunity here. The notion of the Internet of Things is somewhat nascent at this point in time, but it's really growing, and thank goodness for IPv6, because we've gone and exhausted the IPv4 address space, and if we start to make a whole bunch of additional things IP addressable, we're going to have a real hard time doing that. But I think this is an opportunity that hasn't yet exploded, but is about to explode, I think. You know, we at Salesforce, for example, are working with Tesla Motors in Silicon Valley, a builder of electric cars. And Tesla have basically internet-enabled their cars, so they're able to deliver telemetry from the vehicle, you know, back to Tesla, and actually also deliver content back to the owners of the cars, you know, telling them, you know, how efficient your battery is, how efficient your charging environment is, these kind of things. So really creating an intimate relationship between the customer and the producer. So we're also seeing Toyota, you know, building a similar initiative, you know, and they have, you know, sales of multiple millions of cars worldwide. You can imagine, you know, every Toyota on the planet phoning home on a regular basis to Toyota to tell them, what your mileage is, whether the brakes have failed, that kind of thing. So there's a real revolution in the automotive industry segment around making cars part of the internet. Parking spaces and parking meters, this is a great application. I don't know why no one thought of it sooner, but if your parking space and your parking meter is internet enabled, I can actually find out in real time if there's a parking space in the area that I want to go and park in. And then when I get there, instead of having to rustle through my pockets or the ashtrays in the car to find a quarter for the parking meter, I can actually, amazingly enough, use a credit card to pay for the parking space. There's already, companies like GE jet engines. They are highly instrumented these days. They're also now IP addressable, so they gather a whole vast range of telemetry in real time over the engine operating parameters, and they deliver that information, not while they're in the air, obviously, but they do deliver that information back to GE when the aircraft lands and connects to the internet, so that GE can monitor what is a fairly mission-critical part of the aircraft and ensure that the engines are operating properly and that they're maintained correctly within the appropriate parameters and such like. Other opportunities here, smart grid is another enormous one. This is a big market segment in the US. We're enabling all of our home electricity and gas meters so that they can actually deliver information about electricity and gas usage back to your electricity provider. And this allows the electricity provider also, or the utility in general, to better plan for load and consumption, and also allows them to give you as a consumer feedback about how you're using your utilities, whether you should turn your central heating up or down at certain times during the day, that kind of thing. So this whole notion of enabling things to be internet addressable is really sort of making more of a connection between you as a customer or consumer with the provider of the service and the technology. Taxis, there's a great service, or a number of services now in San Francisco, startups like Uber. There's a great app. If you can stand on the street corner anywhere in San Francisco, bring out your smartphone, log into Uber, you can see a little map of where all the Uber cars are. You click on one, and 2 or 3 minutes later, a car appears in front of you, and there's no more hailing taxis as they blast past you at 11 o'clock at night. So this whole notion of internet connectedness is something that's growing, and I think there's some huge opportunities here over the next few years as this sort of area primarily of the use cases matures. So what can we conclude about this theme of mobile? It's being led by the consumer. Enterprise companies, Salesforce, SAP, Oracle, all of the usual suspects are attempting to pursue that because they see how mobile devices are being adopted at the personal level and how those are bleeding into the business arena. The Internet of Things is growing. As a segue to talk about cloud, if you think about 1 billion smartphones out there, even 100 million Facebook hits a day, how do you build a back-end system that scales to support that volume of internet traffic, where you have tens, hundreds, or billions of users? You need huge network bandwidth, first of all. The bandwidth on the pipe has to be incredible to deal with that sheer load of requests. You need an amazing amount of computational power to scale out, to process those requests. And where there's information associated with your application, you need incredible amounts of storage. So let's talk about why cloud is the right technology or theme to address that. Let me first start off with any new technology or trend. There's always a desire by the companies marketing it to come up with lots of buzzwords new three-letter abbreviations, and in cloud, the sort of buzzword or phrase du jour is, something as a service. You have data as a service, enterprise service bus as a service, storage as a service. What it really boils down to is there's essentially, I think, three strata of cloud computing sort of themes. At the lowest strata, you have infrastructure. This is essentially turning your computing resources, your network, your storage, your CPU into essentially a programmable utility, and that's the infrastructure as a service. There's a layer above that, which is what I think of as a platform as a service. Think of it as the cloud operating system. So this is the layer of APIs that you as application developers would start to consume in order to create applications to deploy on the cloud. And then last but not least, there's software as a service, which is essentially a complete packaged application as a service, and that's what Salesforce is involved in. And there are new as a service services invented on almost a weekly basis these days, but it really falls down into these three categories. There we go. To say a little bit more at the highest level about what cloud is and how we view cloud, I think where we're seeing the biggest disruptive change is really in the notion of public cloud. This idea of enterprise cloud, quite frankly, is an invention of lots of large enterprise software companies trying to figure out how to avoid having their enterprise software sales model disintegrate in the presence of cloud. And so there's this notion of an enterprise cloud, which is essentially bringing some of the utility computing models that the public clouds have evolved into the enterprise and really turning your enterprise IT into a sort of internal private cloud. And then again, really as an attempt to preserve brand equity, there's this notion of a secure hybrid cloud where you have some enterprise data in your enterprise that you don't actually want to have leak out into the public internet, and then there's some resources in the public internet that you want to expose to your customers or your employees. And then there's this notion of a hybrid cloud, which essentially has some data in the enterprise and some data in the public internet, and you have essentially a secure connector providing a sort of trust domain across those two environments to share the information that you need to share in order to create your applications. I think for me, when I was creating this slide, I was thinking about, how real is cloud and how serious is the industry about cloud? Is that 5 minutes left? Oh God, I'm going to have to move faster. I knew I would talk too long. Let's just say that there's a lot of big companies here investing a lot of money. Cloud is a very serious proposition here, not just on the sort of public cloud for consumers, but on the enterprise as well. A recent venture capitalist survey, suggests that cloud is changing the way that we're building software. The big drivers, the reason why people are moving to cloud is this notion of scalability. We talked about scalability of business, but now we have scalability of your solution. How do you actually support 100 million users hitting your site every day? You need a hell of a lot of hardware to do that. You also have to be agile. One of the things that I learned at Amazon is the Monday after Thanksgiving, there's an enormous spike in the load that hits the Amazon website. And one of the reasons why Amazon developed the AWS Web Services was to make it easier to turn on more computers more cheaply to deal with that customer load. And so business agility there is important. The other main driver is cost, of course. You've moved, by going to the cloud, you've got rid of a lot of your capital cost and and moved it into your operational costs. So cost is also a driver there. What's inhibiting adoption? It's primarily security here, but I think that the community is dealing with that. This is an interesting slide to show how much bandwidth Amazon's global website consumes versus Amazon Web Services, and you now can see that from a bandwidth consumption perspective, Amazon is now a cloud company as opposed to an e-commerce company, and I think that's quite an interesting fact there. It's not just for large companies as well. Amazon runs an annual competition to identify new startup companies that are using their AWS Web Services. The range of companies that were the finalists this year is quite amazing, from a medical brokering company to online gaming, even I think a 3D medical imaging company were using Amazon Web Services. So the interesting thing about the cloud from an entrepreneurial perspective is that it actually allows you, the barrier to entry is greatly reduced in terms of the computing resources that you need. So cloud is real. It's a very attractive cost model, especially for startups. I think of it as zero to global with just a credit card. You know, I can take an Amex card and I can deploy my application on AWS globally and be able to serve 100 million customers, you know, out of the door, assuming that my software was architected correctly for that scale. I think that fact alone is why cloud is extremely disruptive for small startup companies. Let's talk about big data really quickly, because I think once you lead on from cloud, when you start to have 100 million users hitting you every day, whatever they're hitting you with, it's probably going to amount to a very large amount of data. Today, there's about, I think, 2.7 zettabytes of data globally. That's everything from your family snaps uploaded to, you know, enterprise data. That's an enormous number, and it's only going to get larger. And how do we deal with data at that scale? Here's some numbers which are probably out of date already. You know, Google consumes something like 20 petabytes of data a day. Amazon's S3 simple storage service has over 2 trillion objects in it and services 1 million requests a second globally. Netflix, which is built on top of Amazon, consumes 30% of all of the US network traffic at peak viewing hours, streaming video to Netflix customers. Twitter has over 400 million tweets a day. iTunes downloads 800,000 TV shows and 350,000 movies a day. Facebook has over 800 million updates and 500 terabytes a day. These are enormous volumes of data for storage and also for processing and content delivery. And big data is sort of, you know, defined by the 3 V's: volume, velocity, and variety. Volume in terms of terabytes, petabytes, and exabytes. Velocity, how fast you have to get the data in and out of your platform. Media streaming obviously being the poster child for that. And how do you process it? What do you do with that data when you have it? Are you doing near real-time analytics, or are you doing kind of batch offline processing? And then, of course, there's variety. You know, video, images, documents, telemetry. And the implication of that is it's no longer just relational data. And of course, there's also a few government agencies that are interested in collecting metadata, and that is also, you know, volume and velocity there. So that leads on to the NoSQL revolution. There's been a huge explosion in the number of NoSQL database technologies that are out there. There are literally tens of them. Pretty much all of them are open source. They're all key value stores, and are being applied across the industry. I'm going to skip MapReduce for now because I'm running out of time. Just to give you an idea of what is big data, here is some usage from Yahoo, who were the developer of Hadoop. As you can see, they now have somewhere in the region of 400 petabytes of data stored in the Amazon cloud, and they have, and this is just the Hadoop clusters processing that, they have over 45,000 servers basically processing the 400 petabytes of data in there. So these are some of the big data issues that the market leaders are dealing with. So what can conclude from that? There's only going to be more data, not less. The numbers are staggering. There's an increasing need to store, index, query, and analyze it. And there's an explosion of solutions to deal with that, especially in the NoSQL space. And they all really require a cloud platform to scale. You're not going to be able to do this by going to a venture capitalist, asking them for an awful lot of money, and then popping down to your local hardware store and buying yourself 45,000 servers and enough disk to store 400 petabytes of data on it. So cloud is really a foundational platform for big data. Underlying mobile, cloud, and big data is open source. Open source really levels the playing field, and it's really the only game in town. So how you're an entrepreneur, you want to build a solution. How do you do that? Do I start by designing my processor architecture, writing an operating system, maybe developing a programming language because I've always wanted to do one? I know what would be a great one. No, you don't. How do you focus on your solution? Unless you're Amazon or Google or Yahoo or Facebook or Apple, the list goes on. Where do you get the technology? Where do you get the know-how to create a platform that scales to 400 petabytes and 45,000 servers? The answer is, incredulously, that all of these companies have all of their best developers creating this technology and then putting it up on a website somewhere with a variety of interesting licenses, most of which are essentially free. And you download that and build your application and deploy it on a cloud, and you're done. It's pretty amazing. So open source and open APIs are pretty crucial as a foundation and an accelerator to develop these applications. And it all started from very small beginnings: BSD, Unix, GNU, X Windows, Linux. The big, I think, turning point there was mid 90s with the Apache web server. That really was a knee in the curve there. I'd also claim that probably Java has done an amazing amount for open source. Pretty much all of the interesting open source is written in Java. That's just my opinion. But it's pretty incredible who's using all of this stuff now. I'm going to skip that. Governments are using it. Healthcare's using it. Airlines are using it. I smile wryly whenever an in-flight entertainment system reboots and I can see the X Windows logo come up momentarily. I know that probably the reason that it rebooted was it's executing some of my software. But it's great to see. It's amazing to see the applications of open source and wherever it ends up. And there's an amazing variety of them. Apache, Eclipse, Mozilla. There's even industry market segment open source environments like OpenMRS for medical records. OpenStack, obviously, is another one in the cloud space. So there's an incredibly rich community out there of open source technologies that you can basically, from the operating system up, provision yourself to create a solution with open source software. And I don't know why more people don't do that. Pretty much all of the companies that I've worked for have either created open source and most definitely consume open source. I can't tell you, for a number of reasons, how much of the Salesforce platform, for example, is built in open source, but I can guarantee you it's an awful lot. So the message here is really open source is the way to go. It allows you to focus on the problem that you want to focus on, the solution that you want to create, and allows you to leverage, world-class software solutions in areas that you don't really need to innovate or even operate in. Why should you care? Mobile is going to be dominant. Cloud is the enabler. Big data is the challenge. Open source technologies are the way to deliver it. innovation happens elsewhere. It doesn't have to happen in Silicon Valley, although a lot of it does, and it's a great place to work. But now I think because of mobile, because of cloud, big data, open source, you can innovate anywhere, and you can think globally. You don't have to think about building your application to scale to Scotland or the UK or Europe. You can actually have big ambitions and go out and from day one say, I'm going to build a software solution that is going to be consumed by 1 in 6, 1 in 5, 1 in 4, 1 in 3, 1 in 2 of us on the planet, and you can do that now in a way that you were never able to do, I think, 5, 10, 15, 20, or 30 years ago. And with that, I'm done. Thanks. Questions?
Thanks a lot.
I probably won't have time for questions.
We don't have any time for questions,
Didn't
sorry.
think so. I told you I would talk to
So
you
that was
all.
an encyclopedic coverage of the field, no question about it. And my goodness, what a different world it is nowadays. I remember